This project is the controlling of magnetic orientations and production of soft magnetic composites for electric vehicle applications. Our sponsor was the Materials Research Institute at Penn State University.
The ultimate goal of this project is to show that the parts manufactured from SMCs can be very effective in an electric motor with using a popular industry manufacturing technique and be produced on an industry scale with only few simple modifications.
Stator is a stationary part which converts the electrical current to magnetic force to generate torque. And with the major focus on the stator part, from mechanical engineers' perspective, we look forward to modifying the design by using the advantage of 3D flux path to decrease the amount of copper wire that will be required and replacing the copper winding with the copper hairpins for the better heat dissipation.
There are also some good properties like good relevant permeability and good magnetic saturation.
For our powder, we ball milled iron silicon powder to introduce defects and then pressed it into a part and then annealed the green part in order to get a dielectric coating around the powder.
So what did we find from this process? What we were looking for was our correct form of iron oxide and possible grain orientation, that both can be found via XRD. So above is our raw powder, which is just iron in its ferrite form. And then below that is the XRD data for the annealed powder. As you can see, the small peaks at the bottom give us the correct form of iron oxide for the SMC part, but there was no grain orientation visible via XRD. So this does prove that we can, in fact, make SMC parts with the manufacturing techniques available to us in industry. But things that need to be checked out in future work would be the testing of magnetic properties for these materials to make sure that they're up to par against other silicon steels, and possibly controlling the magnetic orientation of the powder while it's going through the processing steps.